All right. So week four, class starting to come to a close. Working on the entryway, getting that wrapped up is definitely the big focus of week four, first and foremost. Then really your map, and then the last technical task is the simple setup. So an overview of what you're doing in this activity. First up in the first experiment is creating objects that'll work with the grav null, creating, interacting with setups using physics and using the rigid body. So if you remember the minor setups that we talked about, just using the grav null and using the core character actions to make gameplay, you'll be able to start actually building your setups after completing this last set of experiments. Experiment two is all about just creating custom collision. So using ProBuilder, we're able to actually make custom colliders for our objects. So that forklift you have in your scene, you've been probably running through it or just seen it in the scene all month long. Now we're going to use ProBuilder to make a custom collider. So rather than relying on mesh colliders, which can be really expensive, we can use ProBuilder to be our own custom mesh collider for assets that you find in our asset depot or somewhere else online or from an artist. And lastly, in experiment three, we're going to go over object quote unquote snapping. So snapping objects in place using the grav null as well as the inventory system. So we have an inventory system provided to you guys to use in scraps, and I'm going to go over how to actually use it. So really by the end of experiment three, you'll be able to make your door locked. So there's some condition the player has to do in order for them to able to complete an objective, right? So collect an item before the door opens or snap an object in place before the door opens, adding more complexity and adding conditions to when animations happen or when certain events fire off. And then finally, the message system. So giving you guys exposure to some of the in-game tools that you can use and will be using in level design. That way, when you get to level design, you're able just to start building your level and building your mechanics. So let's get into it. So for an object to work with the grav null, it needs the following pieces attached to it. So first, it needs some type of collider component. So when you click with your mouse and you see that green sphere appear, that's actually a sphere that's looking to collide with another game object. Right? It's a trigger volume that basically the player moves around. So that trigger needs to collide with some other collider, right? So a box collider, a capsule collider, a sphere collider, even a mesh collider will work. Just with the mesh collider, make sure you turn on this convex setting. So some type of collider is needed. Next up is the Scraps grav null object script. So you don't have to edit this script. You don't have to change it or know really what's going on in the background. Really, just this component needs to be attached to the object that has your collider. That way the grav null knows which objects it should manipulate and which ones it should ignore. And then lastly is the rigid body component. So I know you guys had some experience with rigid bodies in PMP1, but this allows the physics system to take over. So when we throw it, it's going to react with gravity and with the in-game physics system. So make sure that these three pieces are added to any object you want to interact with the grav null. All right, and then keep in mind when you add the script, when you add the grav null script, the rigid body component will be added automatically. And if you don't have a collider component, Unity will yell at you when you try to add the script, saying there needs to be a collider before the script will get added. All right, so these three pieces are what you need to have for an object to be interactable with the grav null. So you guys will be building just a very simple collider for that tire that's in your scene. But keep in mind, we can make more complex objects. All right. Also, while doing so, the pivot point of where an object's pivot point is located definitely is going to make a difference to your objects and how they interact with the grav null. So if you have the pivot point on the bottom, say down here as an example, it's going to see how the pivot point moves to the center of the grav null itself. When your pivot point's in the center, it moves directly to the center of the grav null. So where that is set, where you actually choose your pivot point, will make a difference with the gameplay. So two ways you can change this are you can use center pivot to set the pivot to the center point, or set pivot will move to a specific location. So you can select a vertex and say I want the pivot point there, and you say set pivot and the pivot moves to that position. Alright? Alright, so here's an example of those complex game objects I was talking about. So here's a boombox that I had built to be interacted with the GravNull. Well, if we look at just the parent, just this boombox parent game object, you'll see that it's just a collider with no mesh. This is oftentimes the best way to build your GravNull objects, is have your parent object just be interacted with the GravNull. So you see this has my three pieces. It has a box collider, it has a rigid body, and it has that GravNull object script. So right now, I could walk up to this thing with the player and pick up this invisible box. Right? Obviously, we wouldn't see much displaying to the screen, but in the inspector, we could see this box moving around, and we could actually see it, if we were like trying to debug things. So we have an object working with the GravNull, and then the children are just the mesh. So all of these children game objects are just the individual meshes. There's no colliders, there's no rigid bodies. You'll see all of these pieces are just the mesh renderer and the transform. So we could build this out of ProBuilder, convert it into an FBX, and then just make it a child of our GravNull object. All right. So pretty straightforward, and it's a cool way for you to set up complex looking objects. So it could be something simple like a crate, or it could be more complicated and a lot more intricate pieces and still work with the GravNull just fine. Alright, so constraints. This should be something that you use a little bit in PMP1, but definitely makes a big difference when you're setting up different setups with scraps. So if you don't put constraints on your physics, it's going to leave the player with a challenging experience. And oftentimes physics has some inconsistencies to it. So by adding constraints and limiting how objects move, it just makes more sense and keeps the gameplay experience much smoother. So if we have like the sliding board, for example, I'm going to constrain it to only move in the z-axis, and you'll see there's also little details here. Here you can see these little railings kind of communicating to the player why things won't move a certain direction, or why I can't move it on the x-axis back and forth. And little things like that can actually be enough to communicate to the player what's going on. So I recommend using constraints and limiting how objects can be moved in your level. So if you have heavy objects, like say you want the player to move cars around, or like slide a dumpster over to the side of a building to jump on top of it, that would be a great example of limiting something in the y-axis. So they can't pick it up over their head, just like move it and push it on the ground. So limiting the movement will oftentimes be a better experience for the player. Alright, so physics joints, these are great ways to add a little bit more interactivity to your setups. So this one in the center here, this is just an object with a rigid body, right, showing how gravity is affected by it. Over on the left-hand side, this is a series of spring joints. So these you can connect to one another and actually create a spring-like scenario. So you could have like a light in your level that's hanging on a spring. I've seen in the past students do cool things with like a platform that's like sitting in water, and when you jump on it, because it's on a spring, there's a little bit of tension and recoil. Different things like that you can do. I've seen plugs, like a big outlet you have to carry over and attach into somewhere, and if you let go of it, it's like on like a bungee cord and retracts back to where it was connected from. Over here on the right, this is just an image of showing how hinge joints can work together. So if you have a chain or a rope or something that you want to have swinging in your level, a series of hinge joints connected to one another can be a great way to do so. So we're going to do a few different activities, and this one down below is directly in your scene that you'll be working on, but this is just showing ways you could use just one individual hinge to create some minor setups. So this one at the top could be anything visually. It could be a telephone pole, it could be a tree, it could be a pillar, it could be part of a wall or some bridge that you knock over to then create a pathway somewhere else. This one could be, part of a ceiling or part of some structure, and we're moving an object out of the way to drop down and make a ramp to lead up. So these are just an example of one individual hinge, but you can connect them together to make a chain or to make a rope of some kind. All right, so here's the hinge joint component. I'm just going to highlight some important pieces about it to help you understand what's actually it consists of. So first up is the connected body. This is an optional reference, and this is how you would connect multiple hinges together. So you'd have a rope, and basically you go down the chain and connect the previous one to the next. So it's like a parent-child relationship, but through physics. You don't actually make a parent-child relationship in the hierarchy. You connect them through the hinge joint, so you know how each hinge is connected and what it's connected to. All right, next up is the anchor. So the anchor and the axis are the two important parts about using any type of joint. So whether it's a hinge joint or a character joint or a spring joint, it's all important that you understand these two concepts. So the anchor is the position. This is where you're actually, where the object is hinging from. So if we have a board and we put our hinge, the anchor is in the center of the board, that means it's going to act like a seesaw, right? It's going to tip back and forth both ways. If we put our anchor on one end, it's going to act like a hinge, like the hinge beam in our scene, where it's going to hinge from one side only. All right, so the anchor is the position where the object is defined, and the axis is the direction. This is which way it's actually going to hinge. So if something's hinging on the X, it's going to fold back and forth. So think of the X, Y, and Z like yaw, pitch, and roll on an airplane. So if we are hinging in the Y, it's going to be like a saloon-style door where you could walk through and it swings back and forth. On the Z would be up and down, and actually the pitch of the actual object. So the anchor is the position, and the axis is the direction in which the hinge is going to spin. Limits are a way that you can actually limit how much movement this object actually has. So rather than allowing it to spin 360 degrees, we only want it to spin in a certain range. So make sure if you want the limits to be used that you turn this Boolean on, because you could set values in here, but if you don't turn this on, those values aren't actually being used. This is a nice thing that we could actually set the limits and then just turn them on and off based on some event being met in the level if you wanted to do so. Right, you can dynamically turn on the limits or turn them off. So basically this is the min and max value the object can rotate. The bounciness is when it reaches a limit, if it's going to just hard stop or if it's going to kind of softly bounce back. This makes it feel a little less rigid and just a little bit smoother of an interaction. And then the contact distance, you can adjust this to avoid some type of jitter. So when a physics object reaches a limit, sometimes it can start shaking and cause some visual issues. So turning up the contact distance is when it's approaching that limit, it will start to return and prevent that jittering from happening. All right, so those are just some debug things, but in a nutshell, that is the hinge joint. So when you're building your hinge beam in your level, try to see if you can come up with other setups or other interactions using those different joints. All right, so the last piece of experiment 1 is going to be the inventory system and getting an object to work with the inventory. So first thing an object needs to be working with the inventory system is a trigger volume. That's really what collectibles are in games, are just trigger volumes that the player interacts with. So we need a trigger volume, then we need to add the scraps collectible script. Alright, so this is just a script that goes on your trigger volume, and now we're going to start using some Unity events coming up. So it's important that we start to associate our our components with the right game objects. So on our scraps collectible, you can adjust this value of like low, I think it's low, medium, and high, and this gives a value of amount of cash that's going to go into your inventory. If you want it to be a required item, like collect the battery and use it, or collect the hubcap, right? Some item that goes into your inventory and then you take it out and use it for something, you want to turn on is key item. And then it's important that here in the key item name, you give it a name. And this is a string, so it's important that you remember how you spelled it and what you wrote for us to then relate or use this later on in the script. All right, and then the last piece is the Scraps interactive script. So this is going to be a new thing, and this is the Unity events I was talking about. If you haven't used these before, it's really handy, makes your life as a designer much easier. And once you understand component-based development, you can use these without having to write nearly as much written script. So on interact, what that means is basically when the player enters the volume and when they press E. So just like we did for the wind turbine, we had the on trigger enter and exit, and then we checked to see if is here was true, right? If that Boolean was true and if they pressed E, that's already handled for you in the Scraps interactive script. So what we need to do is basically when the player goes in the volume and they press E, this is where we can assign what we want to happen. So it's already going to identify when the player presses E. We just need to tell the system, what do we want to have happen? Well, we want the player to be able to collect this object, right, to collect the item. So here we can reference this Scraps collectible component. So I can drag in my game object or get the reference to that component and then call a function. So I'm going to call the collect function, which we've handled for you, which is going to destroy the object and add it to your inventory. All right, so this Scraps Interactive, you're going to use this a lot when you get to level design. This month I walked you guys through an understanding when the player enters a volume and what is going on in the background. So now the Scraps Interactive is going to handle that chunk of code for you. All right, so experiment 2 is pretty straightforward. We're just going to create a collider for this forklift. So here's just some images of my workflow. So starting with a single cube and using extrude, just going to extrude to get the general shape of the object, right? So you can get it there. And then when you're all finished, we just disable the mesh renderer. So the player doesn't see the collider, but they can run into it with their body and other objects will collide with it. I also, in this experiment, I created a separate collider for the fork itself. That's because this object was designed with some type of interaction or animation in mind. So we could snap on the tires and add the hubcaps, and then it falls off the cinder blocks and then rolls over, and then the fork animates and lifts up and moves some objects out of the way for us, right? Or maybe the player manipulates this fork with the grav null and raises it to a certain height and then can jump on it to get to a higher up spot. So I broke it up and had a separate collider for the front, so feel free to either add your own collision to this or set it up for if you want to use this for some other setup to set it up whatever way you feel like doing. Alright, but that's really it for experiment 2, is just getting complex collisions set up. Because you guys will get objects in PNP3 to populate your levels with, but they don't have colliders. They don't actually have collision. So that's something that you're going to want to think about and be responsible for as a designer, is making sure there's appropriate collision on your objects. Okay, and then experiment 3 is about snapping. So first, let's just go over the logic of what we're doing here. And this might change based on what you want to do in your level. This is just one way to approach snapping an object in place. So in this version, there's going to be 3 different variations of the object. One is the physics object. We set that up in experiment 1 to be the one that we pick up with the grav null. All right, this is going to actually be destroyed when it enters into our trigger volume. So the next is a ghost box. This is just a basically a silhouette or a representation to the player that says, hey, an object goes here. This is definitely a little bit gamified, but it's a way to give the player visual cues without having to handhold them or give them text along the way, right? It's just in the world, the player knows something needs to be fixed. And then lastly, there's going to be a static mesh. So the tire is just going to be sitting there, but it's going to be disabled when the level starts. So when our physics object enters into our ghost box, we're going to destroy this one and turn this one on. So this way it's very much set and it's locked in place. If you wanted to have a snapping system where you can attach something and then take it out and remove it to bring it with you somewhere, you'd want to do a slightly different approach, but still definitely possible with the Gravnull and with scraps. All right, so to start it, we're going to need a trigger volume. So we're going to make our ghost box be our actual trigger volume. So we're going to have a mesh collider and then just turn on is trigger. So now this is now acting as our trigger volume. All right, so here we can break down the logic of what our script is doing. So first thing we need is we need a reference to that static object sitting in the world. Right, so we have this tire sitting in place where we want it to be, but it's turned off. So this is going to be our game object for our static object sitting in the level. Then we just have a function for onTriggerEnter, right? Remember that this ghost box is our trigger volume. So when an object enters the volume, first thing we want to do is we want to see if our static object, this game object here, is active in the hierarchy. Because if it's already turned on, then we don't need to do anything else, right? Because it's already been snapped in place. But if our static tire is disabled in the hierarchy, now we want to go forward. So what we're going to do next is we're going to check to see if the object that entered the volume, if it has this component attached to it called snap. All right, so this is just an empty script that we're going to create. So we're going to add this component to our tire, and now this way we could have a stack of tires or a stack of objects, and as long as they all have the snap component, any one of them could be attached into the correct location. So this is a completely empty script. Think of this as like a tag, right? It's another way to identify our objects and group them together. So if other.getComponentSnap does not equal null, right? So if there is a snap component, now we want to go forward. What we're going to do is we're going to destroy the object that entered the volume, which would be our physics tire. We're going to turn on our static object. And now here is for the first time is we're going to send a message to the console. So this would be like writing a print, the player has snapped in the tire, but now this is going to print directly to the Scraps UI. And this is what you'll be using more so in level design to give some feedback to the player. So Scraps message system.instance and then new message. Then from there we can just specify who's sending the message, what they're saying, and then the type of message that it is, whether it's standard, good, bad, or an emote. You can specify a different type. And then finally, the trigger volume that's on this object, we want to turn it off. So that way the player isn't constantly throwing tires in and entering this volume. So once this happens, it's going to deactivate itself. All right, so that should allow us to snap a tire in place, right? Destroying the physics object and enabling the static tire. All right, so the inventory system. So in that first experiment, we got the inventory items working, so the hubcaps can be collected in the inventory, but now we want to actually use them. All right, so there's two main functions you're going to use when using the inventory system. One is getKeyItemAmount, which will return the number that you have of a specific item. So if you want to check to see if you want to have a value to have how many batteries you have in your inventory, you can use getKeyItemAmount to set that variable equal to the number of batteries you have. Down below, can consume key item. This is how you actually use items from your inventory. So check to see if I have one coin. If I do, remove the coin and tell the player I've done so. So here's just two examples of this, and afterwards I'll show you guys where you can see all the documentation for the concepts I'm talking about today. So the first one at the top is using that get key item amount. So I have this integer in my script, number of coins, that equals the get key item amount, silver coins in my inventory. So that way I can always basically use this integer to equal the number I have in my inventory itself. And then can consume key item, this is where you basically have your if and else statement. So if the player has at least one silver coin, it's going to remove it from the inventory and print to the console, you've consumed a silver coin. So here if you wanted to open a door, this is where you could, set the Boolean to true. Otherwise, tell the player you don't have a coin, right? Or it won't play a negative sound effect. So these are the two functions you're going to use. You're probably going to oftentimes use can consume key item more times than the other, but definitely know that these are both available to you. And we're going to use can consume key item to attach our hubcap to the inventory. So what we're going to need is we're going to need a box collider, right? And this is going to be our trigger volume. So like we had before, we had a little exposure to the Scraps interactive script. We're going to attach this to our trigger volume as well. So now we can walk up to this and press E. Alright, so basically the goal of this is when I walk up and press E, I want a hubcap to attach to the front of my tire here, and I wanted to remove it from my inventory. Alright, so what we're going to do is set up our script to do just that. Right? So we're going to have two public game objects. This is pretty similar to how we had three different versions of the tire. We have three different versions of our hubcap. We have a ghost box for the hubcap, we have a static version, and then we have the one in the world that we actually collect. All right, it's three different versions. So we're going to write this function, right? So we have this function here, attach hubcap, and what it's going to do is, I'll get into that in just a second, but you'll see in our interact, it's going to run this function. So when the player walks into the volume and presses E, it's going to run the attach hubcap function. So let's take a look at what this is doing. So first thing is this if statement, checking to see if I have a hubcap in my inventory. All right, so that's the first thing. It's going to check to see if I have a hubcap. So if I do, it's going to turn on the static hubcap. Right? It's going to disable the ghost box. It's also going to send a message to the UI just saying I've snapped a hubcap in place. And then lastly, and definitely an important one, it's going to disable the Scraps interactive component. Why I'm doing this is so if the player goes and collects 5 hubcaps, they can't walk up to this and then press E over and over and over again and use all their hubcaps. As soon as they've consumed one, it's going to remove it from the inventory, it's going to turn it on, turn off the ghost box, and then disable the interactive so they can't continue to interact. So if they don't, this else statement down here is if they don't have at least one hubcap, it's going to send a message to the console just saying, I have to find a hubcap, right? Or there must be one around here. We could also play a negative sound effect or give some type of additional feedback to let the player know what's going on. Alright, so the last Perforce action I'm going to talk about for the month is reconciling offline work. This is definitely an important action to understand and really understand when it should be used. So overall, it was designed to use if you don't have a stable internet connection, or if you're running into a point where you don't have internet for a certain period of time. So what this allows you to do is work on your local computer, and then when you have an internet connection, submit all of your files back to the depot. Alright, so what it actually does is it compares a folder on your workspace, or the folder that you select to reconcile. It's going to compare with what's on the depot. So it's going to look for files that are new, and it's going to add them. It's going to look for files that are missing, and it's going to delete those files. And it's going to look for files that have changed, and it's going to check them out. Alright? So if you're ever using this action, only ever use it on your assets or your project settings folder. Right? If you go higher than that, if you go to like the root of your project and hit reconcile offline work, it's going to scan your whole project for new files. Well, some of you might have already experienced some problems with your library folder this month. That's what you can run into those issues if you reconcile your entire project. So it's going to scan your whole folder and be like, hey, that library folder, that's new. I'm going to mark it for add, and then it's going to get added to the depot. So don't ever go above assets or project settings when you're using the reconcile action. All right, so I really want to stress that I really don't encourage new users of Perforce to making this your main workflow. All right, it can help it can help catch issues that come up in case, what's on your computer doesn't match your teammates. You can reconcile to see what files you might have missed submitting. But if you make this into your main workflow, it can cause a lot of problems rather than fix those issues. Right? So remember that workflow that you've been doing all month, where you check out the file, you edit the file in Unity or in some program, and then you save and submit. Right? So check out, edit, save, and submit, and just repeat that process for files that are on the depot. All right, so now here's just a look at what you'll see when you reconcile in Perforce. So if you select like your assets folder and hit reconcile, it's going to scan the whole assets folder. So you see here it's broken up into 3 separate windows. The window at the top is going to be files that are different on your computer. These you'll see get represented by that little tinted blue icon to represent files that are modified. So these files are going to be checked out. These ones in the middle section here, it's saying that they're in my workspace, but they're not on the depot. So it's going to mark these ones for add. And then the ones down here, these are in the depot, but they're missing from my workspace. So what it's going to do is mark the ones on the depot for delete. So you could definitely see how if you aren't quite paying attention, you just see all these files and hit reconcile, you might end up in a sticky situation. So it's better to review these changes, right? So the one at the top, these are going to be checked out. So actually make sure you want to check out and change these files. If not, you can deselect them from this list. These ones here are going to be marked for add. So again, you can go through and make sure these are files you want to add. If you see your library folder in here, it's probably not something you want to actually go forward with. And then these ones will be marked for delete. So definitely review these windows and review the change list before you hit reconcile. Once you hit this button, this is what's going to send it to a change list. So once you hit reconcile, all of these files go to a change list, and then you can submit from there. So if you understand how checkout, how mark for add, and how mark for delete work on a technical level, then this can be a new tool you can add to your tool belt. But if you try to make this your way to avoid using Perforce, it can sometimes lead to more complications than it can actually solve. So still get in the habit of manually checking out your files and manually marking them for add, but this can be a good way to scan your whole folder every once in a while and make sure nothing was missed, nothing was forgotten to get added to the depot or wasn't correctly modified. All right. So thanks for joining me. I'm going to go ahead and turn off the recording.